You also need to be able to calculate energy changes and use the equations to rearrange. You get given the equations on the equation sheet for 2022. And if it's not 2022, you'll have to learn these equations, apart from the elastic energy one. In this question up here, I've got 1,000 joules of gravitational potential energy, 50 kilos for mass, 10 newtons per kilo for the gravitational force, and a height of unknown quantity, which is what we're trying to find in this question. The first thing I've done is substitute the numbers into the equation. I'm going to simplify this. 50 times 10 is 500, so I've now got 1,000 equals 500 times by the height that we're trying to find. We want to get the height on its own, so we do the opposite of times by 500, which is divide by 500. I type it into my calculator just as it looks on my page, making sure I've got the right number of zeros, so don't make any silly mistakes. 1,000 divided by 500 equals 2. Height is measured in meters, so add my unit and make it clear that that is my answer. To do a more complicated rearrangement, I've got kinetic energy is half times mass times speed squared. I put the half as 0.5, it's easier to work with and rearrange. In this question I've made up these fictitious numbers of 1,000 joules of kinetic energy, 0.5 for the half, and the mass I've given as 50 kilos, and it's the speed we're trying to calculate in this question. So speed we're trying to get to. 0.5 times 50 is 25, so now I've got 1,000 equals 25 times speed squared. Again, not got speed on its own, so I need to rearrange. The opposite of times 25 is divide by 25, so 1,000 divided by 25. Again, get the calculator, make it look exactly like it does on the page so you don't make any mistakes. 1,000 divided by 25 equals 40. So I now have my speed squared equals 40. But I'm not interested in speed squared, I'm interested in the speed. So I need to do the opposite of the squared, which is the square root of 40. So that square is being cancelled out by the square root. So square root of 40 equals speed. On the calculator, square root of 40 is 6.32455532. And if you're unsure of how many significant figures to put, either write the whole calculator screen or write it to 3 significant figures. That's my advice. This rearrangement is exactly the same as for the elastic potential energy equation, which is elastic energy equals a half times the spring constant times the extension squared. Again, don't forget about the squared. And if you're given two lengths of an object, you need to find the difference. For example, it could be a spring getting squashed, a bungee rope extending, it doesn't matter. For example, let's say we've got a spring of 50 centimetres and that's been compressed down to 20 centimetres. To find the extension, we need to do 50 take away 20, which equals 30 centimetres, but we need to convert that into metres. There's 100 centimetres in a metre, so we divide by 100, getting an extension of 0.3 metres. And then when we put it into the equation, we don't forget to square it. That has to be done. Don't forget that mass is always in kilograms. If it's not a mass, any other unit with a K in front you need times by 1,000. Any unit with a capital letter M in front you need times by 1,000,000 to convert.